A coin is tossed 3 times. If x is a random variable, given number of heads that arise, construct a table showing the probability distribution of x. Now, a coin is tossed 3 times. So, first of all, we need to generate the sample space of tossing a coin 3 times. This is sample space of tossing a coin 2 times. We have head, 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 tail, tail, head, tail, tail. This is the sample space of tossing 2 coins. Now the third tossed, this is the sample space. We have tail and we have a head. So we want to generate sample space of tossing a coin 3 times. The one at the top here is the sample space of tossing a coin twice, and the one vertical here is the sample space of tossing a coin once. So this is tail, head, head. So we're going to have tail, head, head, tail, head, tail, tail, head, tail, 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 head, tail, tail, head, and lastly, here we're going to have tail, 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 tail. This is head, and we have 2 head here. So there we have head, 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 tail, head, tail, head, head, tail, tail. So we have head, tail, tail. So if you look at the sample space here, we have an 8 in number. 1, 2, 3, 4, 5, 6, 7, 8. And the best way to know the sample space of this particular event, you just have 2 raised to power n. N is the number of times the coin is tossed. The coin is tossed 3 times. So here we're going to have 2 raised to power 3, and this is going to give us 8. So which means the number of sample space we're expecting in this experiment is 8, and therefore we have 1, 2, 3, 4, 5, 6, 7, 8. Now we want to construct. Now let's say x should represent number of head. X should represent number of head. So in this point now, we probably could have 0 head, 1 head, 2 head, or 3 head, because the coin is tossed 3 times. So the maximum number of head we can have is just 3, and the minimum is 0. You mean neither have not to have any head. So this is the probability distribution of x. We have f of x here. So how many number of times head does not appear at all? And it is only in this case, this tail, tail, tail. There is no head that appear in this tail, tail, tail. So this is going to give us 1 divided by what? Divided by the total number of sample space. That is 1/8. Now how many times head appear once? Head appear once here, 1. Head appear once here, 2. Head appear once here, 3. So that is 3 divided by 8. Now how many times head appear twice? Head appear twice here, 2 times 1. Head appear 2 times here, 2. Head appear 2 times here, 3. So this is also 3/8. And how many times head appear 3 times? It only appear once, which is head, head, head. Only one. So here we have 1/8. So this is the probability distribution of this particular questions here. So x could be 0, 1, 2, 3. It cannot be more than 3. And if you remember in the probability, in the law of probability, so which means the summation of all these probability distribution will be definitely give us 1. So if you add all of this together, it will give you 1. And when you're talking of probability, you cannot have probability that's less than 0. So probability ranges between 0 and 1. So that is highest. There is another way of doing this, and what is the way? That is using tree diagram. using tree diagram. How do we do that? So this is another method. Another method of getting the sample space here. So how do we do this? We say for the first toast, we could probably have a head or a tail. So this here we have head, tail. The second toast here we have another head, tail. Here we have a head, tail, and the third toast we have head, tail, head, tail, head, tail, head, tail. So if you look at this trend now, we have head, head, head. So this is head, 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 tail, head, head, tail. We have used all of these. Now we want to move like this. Now we have head, tail, head, head, tail, head. We have head, tail, tail, head, tail, tail. Now let's move down from this tail. Now we have a tail, head, head, tail, head, head. We have a tail, head, tail, tail, head, tail. We also have a tail, tail, head. This tail, tail, head. And we have a tail, tail, tail. This is tail, tail, tail. This is 1, 2, 3, 4, 5, 6, 7, 8. So it means the sample space here is 8 in number. If you don't want to find the sample space here, you can also find the sample space in this way. And the third way of getting the probability distribution is to use a Pascal triangle. Using Pascal triangle, because this agree with binomial distribution. We can use Pascal triangle to get the probability distribution of this coin that is tossed 3 times. Now let's start with this. A coin is tossed 3 times. The first time we have 1, 1. The second time we have 1, 2, 1. And the third toss we have 1, 3, 3, 1. That is, it always starts with 1. 1 plus 2, 3. 2 plus 1, 3. Then we have the final as 1. It always starts with 1 and end with 1. How do we get this 2 here? We have a 1 plus 1 give us 2. So now, and we know that the total number of sample space is 8. So definitely the probability distribution of this function will just be divide everything by 8. 8, 8, 8. So this is the probability distribution of the event. So when x equals to 0, x is 1, x is 2, x is 3. And what does x represent? The number of hairs that appear. X is the number of hairs that appear. So we can either find the probability distribution of the function in this way, or that way. An on holds 5 white and 3 black marbles. If 2 marbles are to be drawn without replacing it, and x denotes the number of white marbles, find the probability of x. What does x stand for? X stands for white marbles. So now here we have white marbles. We have it to be 5. Then black marbles. We have it to be 3. So the total number of marbles here, we have it as 8. Now x represents the number of white marbles. And what do we need here? We want to find the probability distribution of x. The probability distribution of x. So how do we find the probability distribution of x now? So in this case now, it is either what's it called? White does not appear at all, which is 0, or white appear once, which is 1, or white appear twice, which is 2. So which means the value x could probably take is either 0, 1, or 2. 0, 1, or 2. And there is a keyword here. This is without replacement. Without replacement. If two marbles are to be drawn without replacement. Okay. Let's start with like assuming that when the two marbles were drawn, none of the marbles was white. So which means we are dealing with only 3 blacks. That is 0 white marbles was drawn. So it means the first that was drawn is black. So and what is the probability of drawing black first? That is 3/8 multiplied by the second marbles that was drawn is also black, and that is 2 divided by 7. Why do I have it as 2 here? Because it's without replacement. The first one that was drawn is black. So when you are drawing the second one, that means it has reduced by 1. So that's why we have 2 here and we have 7 here. So if we multiply this together, 3 times 2 will give us 6 divided by 56. So we need to divide this. We can still divide it further, and this will finally give us 3/28. So which means no white marbles was drawn. The probability distribution is going to be 3/28. That's the probability of the two marbles, none was white. Okay. Now let's now assume that one of the two marbles that was drawn, one of the two marbles that was drawn is white. So it will come in this order, like the first one that was drawn is white and the second one is black, or the first one that was drawn is black and the second one is what is white. So let's say one white marble, so the first marble that was drawn is white. So in this case, and don't forget we have a white marbles, we have 5. So the probability here is going to be 5/8 multiplied by the second marble that was drawn is black. The total number of blacks still remain intact, which is 3. So we have 3 divided by 7. This has already reduced. Then plus the first marble that was drawn is black. So here we're going to have 3/8 times the second marble that was drawn is white. This has reduced already. So we have 5 is still intact. So we have 5 divided by 7. So 5 times 3 we have 15 divided by 8 times 7 still gives 56 plus 15/56. If you add all of this together, we have 30 divided by 56. This we can split it further, and if you do that, we're going to have 15 divided by 28. So which means the probability distribution of having one marble out of the two marbles that were drawn, we have 15 divided by 28. Now third, we have 2 white marbles. 2 white marbles were drawn. So in either way, either the first one is white or the second one is black. That is the only way we can have it. So the probability of having the first one to be white is 5/8 multiplied by the probability of having the second marble to also be white is 4. This is going to reduce because we have already drawn the first one. So we have 4 divided by 7. And if we multiply this, so we have 20/56. So therefore the probability here is 5/14. 5/14. So we have 5 divided by 14. So this is the probability distribution of X to be white marbles. If 2 marbles were drawn, we will have 5 white and 3 blacks. For 0 marbles to be drawn, we have 3 divided by 28. For one of the marble to be white, that is going to give us 15 divided by 28. And to have the 2 marbles to be white, we have 5 divided by 15. And if you add all of this together, it's definitely going to give us 1, because probability of all sample space, all the sample space, when you find the probability of all and you add them together, that you summate them together, everything will definitely give you 1. So this is just for discrete distribution. Is not applicable. This method is not applicable to continuous distribution. It's only applicable to discrete distribution.